The next thing that we re-look at as a preparation for our limits is rationalizing. Now, in grade 11, you rationalize denominators. So in grade 11, if you had something that was 1 over the square root of 3, you multiplied the top and bottom by the square root of 3, and that changed your denominator, which was an irrational number, square root of 3, to a denominator that's a rational number, 3. And then in grade 12, you found out that if you didn't do that, it didn't matter on the exam. They're not going to take off a half a mark for not rationalizing your denominator, which made you wonder, well, why did we do that in grade 11 if they were just going to tell us we didn't need to do it in grade 12? What's the history around rationalizing numerators and denominators? Well, we see some of the reason now in grade 12 in calculus and limits. But back then, we didn't really see why we needed to do that. Now, part of the reason was before calculators, it was very hard to divide by an irrational number by hand. It took a long time. It wasn't as hard to divide by a rational number. Even if your number on top was an irrational number, it was quicker to divide by a rational number. So, for the sake of time, if you actually wanted to do this by hand, this would be easier than 1 over the square root of 3. And so that was part of the process. Now, over time, they've taken things out of the math curriculum because of the invention of calculators, right? You no longer have to, how would you do? By hand, square root of 20, 5 decimal places, go. They don't teach that anymore. That used to be part of math curriculum. There's a method. There's a technique for figuring out square roots to as many decimal places as you want by hand. Okay? Now there's a new technique. Type it into my calculator, push enter. And we need to adjust because sometimes technology, it's better for us not to waste our time doing long, monotonous things. We could teach you. It's a process that you could just do over and over again. But instead, we want to get at what kind of mathematical thinking do you need? Because knowing a method to do something, we still have that in lots of areas of math. You learned a method for solving for x in a square root equation. So we still have that idea of using methods, so we haven't lost that. But now it's not really a good use of time to do the square root of 20 by hand. So that's taken out. But this idea of rationalizing, especially when you had a binomial, like the square root of x plus 3, where you had to multiply by the conjugate. Now the word conjugate, the definition of a conjugate is the same thing. Notice these are the same, just the sign in the middle is changed. That's the definition of a conjugate. And that gets rid of your square root because it's based on the idea of a difference of squares. If I multiply a difference of squares together, it squares the first one and it squares the last one. And if either of those or both of those are square roots, they're going to be gone. It's going to get rid of them. Now in calculus, sometimes we're going to have to rationalize the numerator or the denominator. So in this one, we're wanting to rationalize the denominator. What we're going to look at is if I think of a difference of squares and I think of the conjugate, in order to get rid of that square root, I'm going to multiply by the same thing with a different sign. On the top of your equation, you can just distribute. So you're going to get 2 square root of x plus 3 plus 4. And on the bottom, when you multiply this out, this is a difference of squares. So you can say, well, I'm going to get the first one squared. Well, if I did the first one squared, I'm going to get just x plus 3 minus the second one squared, which will just be minus 4. And then we can simplify this and it just becomes x minus 1. So there's 3 more there I'd like you to try. Here's the first one. You can check how you did. Now, what I've written here as a final answer, I mean, I distributed the 5 through, simplified it, and in the end, I factored the 5 out again. What we're going to find is often we want to have our answer as factored as possible because it allows us to simplify. In this case, it really made no difference because factoring that 5 out didn't make it more simple, didn't allow us to simplify the 5 over negative 2, but in some cases it can. And the really nice thing about your textbook is all of the answers in your textbook are in the most simple form mathematically that's accepted. And so one of the algebraic skills that you have to develop in this course is once you've got your answer, it sort of becomes like a mini identity. You look at the answer key and you look at your answer. They're probably both right, but can you manipulate your answer algebraically to get the answer at the back of the book? So for this third one, I'm going to rationalize the numerator. You multiply by square root of x plus 4. Now, the top is a difference of squares. That's going to give you an x minus 16. Sometimes we get tempted to multiply things out too early. Like, you could have multiplied out the bottom. You could have distributed things and got something. But if you take a moment to look at what happens, we say, hey, on the top I have an x minus 16, and on the bottom I have an x minus 16. And those factors are identical, so I can cancel them out. Now a little bit of reminder about graphing stuff. Remember when you graph rational equations, that when something cancels out, that causes a hole to be in your graph. So in this equation, we would have a hole in our graph, because once we simplify that x minus 16 out, our equation becomes 1 over the square root of x plus 4. And there's going to be a hole when x is 16. And to find the y-coordinate of the hole, to find this 1/8, what do? We plug 16 into your simplified formula. Square root of 16 is 4. 4 plus 4 gives you 8 on the bottom. And that's how you find the y-coordinate of that hole. This one in particular is going to be one that we do with limits, because we're going to be asking, what happens? What happens to this equation when x gets really close to 16? Because 16 is a non-permissible value. And we're going to find out when x gets really close to 16, y gets really close to 1/8, because that's that hole in that graph. So for rationalizing this one, a couple of different ways to multiply out the tops. For one, noticing the tops is a difference of squares. If I multiply x times x, I'm going to get x squared, and square root of x times square root of x is going to give you x. That's going to give you x cubed on the top. You could have also changed your x in front to a square root of x squared, which would have made your number out in front an x cubed, which I've written up in blue above here. And then if you multiply x cubed, square root of x cubed times square root of x cubed, you're going to get x cubed that way as well. So we get x cubed minus 1 on the top. Notice I wasn't overly gung-ho about multiplying out the bottom, because I knew the top made a difference of squares, so that makes sense to multiply out. But the bottom is already factored. And usually if you're going to want to simplify things, a factored form is an easier way to simplify it than a non-factored form. What we get on the top is our x cubed minus 1, which is a difference of cubes that we just learned about today. So our difference of cubes, we could factor, because x cubed minus 1 is going to be x minus 1 times x squared plus x plus 1. And then that x minus 1 could cancel out with that already pre-factored out x minus 1 on the bottom. And this one as well would have a hole in the graph when x is equal to 1. Again, I found that y coordinate of 3/2 by plugging x equals 1 into the simplified version. So you'll see you get 3 on the top and 2 on the bottom.